Is anybody home? Is anybody there? Alright, we're here at gotomath.com. I guess nobody's home. Fundamental Theorem of Calculus, and we are doing 2.1. Is that it? Something like that. I think I need to put a parentheses in here. Maybe I'll get that fixed someday. Use the Fundamental Theorem of Calculus to find the definite integral. So hopefully you've done indefinite integration. You've probably done definite integration. Who knows what you've done. I'm sure you've done indefinite integration by now. Anyway, let's just write this down. Everybody write it down. We're going from 25. And this is going to be a big number, folks. This is going to be a big number. I need to probably go into the programming, and 25, that's not necessary. It's a parabola. It's conch. Oh my gosh. It's going to be a huge number. Let's go ahead and write everything down here. So we got the integral going from 3 to 25, x squared plus 10 and dx. Okay, so I'm going to try to, I guess first thing I need to do is let's define a couple things. F of x is x squared plus 10, right? That's f of x, okay? And alright, so I'm going to write down, let's see, what can we write down? The fundamental theorem of calculus. I'm going to state the actual theorem, fundamental theorem. You're like, man, the fundamental theorem, we're just not talking about that? Alright, fundamental theorem of calculus. Let f be a continuous function on the closed interval. We'll say that with some, just by voice. Should say on the closed interval AB. Let's see, and capital F. Let's see, be an antiderivative. I'll be glad when I get one of those touch screens so I can write directly on the screen. I have really good handwriting, but it doesn't look like it. And F be an antiderivative. Let's see, F an antiderivative. I just forgot what the heck I was doing. Let F be an antiderivative of little f. That's the name of our function up here. Yep, on the interval AB. So we'll just add to that, on the interval. You can write the interval AB there. That's a closed interval, by the way. Then we can say, going from A to B, our function f of x dx is equal to f of b minus f of a. So how do we interpret this? Well, it's not too bad from what we got. So you remember, surely you know how to do indefinite integration. That's kind of a big deal there, right? I'll go ahead and write 3. We'll rewrite the problem. 25. I mean, you gotta know how to do indefinite integration before you really do this. Okay, so this is x cubed, right? The integral of x squared is x cubed over 3 plus 10x, and then we put this bar here and go ahead and write 3 and 25. Now when we were looking for the antiderivative, remember, in indefinite integration we just write plus c and then we're done. But this way, we go ahead and do it this way. Notice we don't write the plus c. We don't need to because the c cancels out. So we end up with 25 cubed over 3 plus 10 times 25 minus, put a big parentheses here, okay, don't forget that, and then we have 3 cubed over 3 plus 10 times 3, close parentheses. All right, get out, you can do that in your head, whatever you want to do, I don't know. Anyway, all right, so when the smoke cleared, you should have gotten 16258 over 3, and let's get a decimal representation of that. Okay, I'll just say approximation here. 5419.333 da 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 da. It goes on forever there. I should put a bar over this 3 here, I guess. Anyway, so 514. Anyway, that's the answer right there. Let's just click here. 162. Ooh, excuse me. Anyway. Okay, so that's all there really is to the fundamental theorem of calculus. There is a second fundamental theorem of calculus, by the way, which is really cool. I think it's cooler than this one. But anyway. Okay. However you want to define cool, what's cool. Tell you what's cool. Head on over to go to math.com, practice, I'll get you through calculus. And you won't ever have to spend that big bucks again. And if you're in high school, you can go ahead and work through this website and just go to the university and take the test and pass it. You won't have to take the class and probably spend a whole lot less getting those credits too. All right, see you later, bye.